Hey there. In this tutorial we're going to use a more challenging savings problem where we're going to make annual deposits into a bank account, but then we're going to follow those annual deposits up with a series of withdrawals. This is the same type of savings problem you'll use when you're setting up retirement savings, right? You'll need to save a certain amount per year for retirement, and the amount that you're going to need to save each year is going to depend on your cost of living when you retire. The same thing with a college savings problem, which is what we're going to use here, using my daughter June as an example. We're going to balance the cost of college per year, hopefully, against annual savings that we can make, or that I theoretically will make. So I looked it up online, and roughly, if you're budgeting for a 4-year cost of college, or a cost of college for a 4-year school, right now it's going to cost you about $25,000 per year. So I'm going to enter that in as my cost of college. When we get to the chapter covering inflation, we'll look back at this and say, aha, we underestimated that because college costs are increasing every year. So this number that I'm actually going to have to pay out is going to be larger. I'm going to have to save money now to pay for college. It's getting more and more expensive. And let's assume, theoretically, that we can get 8% per year on our savings. That's about the average that the stock market would yield over time. Of course, it's risky. You may gain 20%, you may lose 20%, but tends to average over time about 8. So to set up this problem, I have this chart where I've got a number of columns. I'm going to use age, my daughter's age, or when you're doing the savings problem for your homework, it would be your age. And then lapse, this allows us to keep track of the number of years of savings and the number of years of spending. And I think it's very helpful. We're going to have a beginning balance, our savings at the beginning of the year, followed by either a deposit or a withdrawal. And then we'll create this column net that allows us to add those two up. So say we were still depositing but withdrawing. By using both of these columns, it allows you to be flexible when you set up future problems like this. The interest is the amount of interest we'll earn on our savings. And if we add up our beginning balance, our net deposit, and our interest, we'll get our ending balance. And that ending balance, say our balance on December 31st of 2014, happens to be the exact same balance as January 1st, 2015. Okay, let's get started. Let's say that we're saving for my daughter June's college education, and she's about to turn 10. And let's say that I'm going to start on her 10th birthday, and that I'm going to save for her, make one deposit every year on her 10th birthday, on her 11th birthday, all the way each birthday until she turns 18. At which point, she's going to go off to college, and then I'm going to need to make 4 withdrawals when she's 19, when she's 20, when she's 21, and when she's 22, because that's her 4 years of college. So the lapse allows me to determine essentially my N, right? My number of years of savings and my number of years of withdrawals. So I'm going to make deposits for 9 years. I've got 9 years to save for her college career, right? And then I'm going to have to withdraw for 4 years. So I could put this line here, and I'm do this at my own risk. It's better to put lines in at the end because Excel will move them around and delete them depending on what else we do in the problem, but it gives us a good visual, right? We're going to be making a series of deposits here, and then we're going to make a series of withdrawals for the next 4 years. So the amount that we're going to withdraw is going to be that $25,000 a year, negative $25,000. Give it an absolute reference so I can just drag it down, right? And this is what we're looking at. I need to be able to make this withdrawal of $25,000 per year while she's in college. So in order to do that, I need to make a certain number of deposits here. So let's address this problem. One thing that I need to fill in is I've got my cost of college, I've got my interest rate. Just when you use Excel and you use the PV formulas and the PMT formulas, it's nice to have your N. So I've got 4 years of college, and I've got 9 years of savings. So we do this problem in 2 steps, really. And to do these 2 steps, we're going to rely on section 2.2 in the book, which is present value of annuity, And then we're going to rely on section 2.7 in the book, which is using the payment function to solve future value problems. And we'll start with the amount that we need at the start of college. That's going to be our first step. We need to say, how much do I need to have in the bank here, right? What does that number need to be in order to make withdrawals of $25,000 per year? So that's going to be a present value of an annuity, right? How much do I need now in order to make withdrawals later? Or similarly, we could say, what's a series of future payments worth in today's value? So we use PV, present value. Our rate refers to our interest rate. Our number of periods refers to the number of periods of withdrawals, right? Because we're looking for the present value of these 4 withdrawals. So we've got 4. And our payment is going to be a withdrawal, so a negative $25,000. Future value, we're going to deplete it to 0. And the type, that is, are you going to make these withdrawals at the beginning of the year or the end of the year? And we're just going to simplify things by saying that I'm going to pay for college up front each year, right? Because the problem specifies. You always want to check the problem. If it says end of the year, you leave it blank. If it says beginning of the year, you do a 1. And if it's your personal life and your savings, always start saving now. So it'll be a 1 for your regular life because you're smart and you'll save now. Present value, $89,427.42. That's what we're going to need. So this number here, we need to magically make it, or this number here, this will be the same number. We need to figure out what deposit we need so that when we create our table, this, will be $89,427. So to figure that out is our second step, section 2.7, future value of using payment to solve future value problems. We use PMT. Our rate is that same 8%. Our number of periods this time is 9 because we're going to be making 9 equal deposits. Our present value is what we're going to start with, which is 0. We can leave it blank. But our future value is we want to save $89,000. We enter a negative number then so that our deposits will show up as positive. And our type is 1 because we're going to deposit today. So we're going to need to deposit $6,630. So now we've got these 2 numbers, and our third step is to set up this table to make sure we're correct. Because if we made a mistake anywhere in here, this number here won't equal 89,000, this number here won't equal 0. So today, let's assume June has nothing in her savings account, and I'm going to go ahead and deposit this withdrawal, or this deposit of $6,630, giving it an absolute reference because I want to be able to drag it down. Our withdrawal is going to be nothing, so I'm going to leave it blank. And our net is just going to be the sum of these 2 things. Okay? Our interest, the amount of interest that we're going to earn, is going to be based on our interest rate of 8%, giving it again an absolute reference. But it's going to be based on the amount of money that we've had in the bank all year, which will be the balance we start with plus our net deposit that we make at the beginning of the year. So we'll earn $530 roughly in interest. So our ending balance will be equal to what we started with, what we deposited, and what we earned in interest. Making sure to reference our net deposit so that we don't have to change this formula when we get down here to taking our withdrawals. Well, lucky for us, the amount we have at the end of the year and the amount we have at the beginning of the year, those are just the same thing. Again, we're going to deposit $66.30. We're going to withdraw nothing. So our net deposit is equal to the deposit we made and the withdrawal that we didn't make. And we're going to earn interest of 8% with an absolute reference on our beginning balance and our net deposit. Great. More interest at the end of the year. We have our January 1st balance, we have our deposit, and then we have the year's, we have our net deposit, and then we have the interest that we earned throughout the year. So now we can just take these and drag them all down, and we'll lose our pretty little line, but that's going to be okay. And we end up with $89,427.42. $427. That's the first thing that you want to check. Does this number equal what you think you should get here, right? If not, go back and check your cells. Make sure that your interest is based on your beginning balance and your net deposit. Make sure that your ending balance is based on your beginning balance, your net deposit, and your interest. Make sure that this number is the same all the way down. Double check that interest grows, and by then you probably will have found your problem. So now we know that we're going to essentially we're not really going to change the structure of our problem. We could take this down one by one, right? We could create our new formulas again. 89,000. Our deposit is 0, so we'll leave it blank. And our net deposit is going to be equal to our deposit that we didn't make plus the withdrawal that we did. Interest and ending balance pull down automatically there. So we can just grab this and bring it down. And what we're looking for is that this number here, it's our second check, it needs to equal 0, right? That means that when you send your kid to college, or when I send my kid to college, after she's done with college, I've used up all my savings, right? I've used her college savings. We used it to send her to college. Perfect, right? All right, so let's try this problem another way using a tool called GoalSeek. GoalSeek is lovely because it can rapidly find an answer to something that might take us a much longer time to do. So to change we're going to change our model, and we're going to change it so that all of our deposits no longer reference our annual deposit cell. We're going to change them so that they reference this GoalSeek cell. So I'm going to start here by just putting some arbitrary number in there, like $10. And then I'm going to change the reference for the table so that it references this GoalSeek cell. I need to drag it down so all the deposits reference that GoalSeek cell. And then you can basically see that if I only deposited $10 per year, the sum total of our savings for June's college fund would be $134, which would leave her roughly $121,000 in debt by the time she got done with college, which, you know, if we can prevent that, or prevent some of that, it would be awesome, right? So we're going to have to then use GoalSeek to change this number. And if this number changes, right, so pause here. If you're using your homework, if you're using this example to model for your homework, go back here and change this number to something else, 4,000. Make sure all these 4,000s change, right? And make sure that these numbers change, right? If we say 4,000 per year, she'll only be about 4,800 in debt. Okay, you know, we'll take that. So now let's go to GoalSeek. All right, so when you're looking at GoalSeek, don't think that there is something that is called a set cell. Read this like a sentence, right? Set the cell blank to value blank by changing cell blank. I'll do it again. No, not a data table. All right, so the first thing is the cell that we want to, our goal cell, right? So when we're done saving and she's done going to college, we know that there's going to be nothing in this final cell. So that's our goal, right? We're seeking the value of this input that will make this input or this outcome be 0. So what input will make this output 0? So we start with our output. So we want to set cell H25 to 0, because that's our desired output, by changing this cell, our annual deposit. We tell it OK, and it just brilliantly comes up with the same number for us, right? GoalSeek can do just about anything. So we can use either our annual deposit that we solve for using payment, or we can use GoalSeek, or we can use both. And I recommend using both, because if you can do things two ways, you know that at least one of them is right? Because if you get different numbers, you know there's a mistake somewhere. So if those two numbers match, then you're pretty darn sure you got the problem right. All right, good luck. Happy calculating. Yeah, see you soon.